Today we have a tutorial on path following in processing. Hello everyone, my name is Hadil and today I'll walk you through the steps of how you can make one of these path following animations with whatever generated brushes you make. Let's hop in. First things first, let's talk SVGs. I'll be using the Geomerative library to load an SVG and generate the points on the shape. So I'll show you how to export your SVGs from Illustrator so it's not broken when you import it into processing. A big no is using the export feature. And that you can find in the File menu. The shapes are never right and almost all of the curves are straight lines when you import them into Geomerative. It's so weird. So what I do is save a copy from here and make sure that I check the artboard and make it an SVG. And I'm going to put it inside of my sketch because I've already saved it and I have a data folder that I added there and you can save it over here. So I'll just call it A for the letter A, use artboard, and because we don't have any other artboard, so it's just going to be the first one. And then I'm going to save it. And I use SVG 1.0. I haven't really tried any of the other ones, but I just know this works, so I'm sticking with it. It's perfect to every time. There are also online SVG creators. If I find the one I tested for the letter A, I'll link down below. It also saved the SVG correctly for my sketch. Next, let's see how we can use the Geomerative library to import the shape and convert it into points. First, make sure the library is installed. You can go to Sketch, Import Library, Add Library, and then look for Geomerative. Install it, and then you're good to go. Now we can import it into our sketch. As per usual, I have my colors set up and I also add the pixel density method inside setup because I have a 5K screen and sketches are pixelated when I don't use it. So this doubles my canvas size when exported, which is really great. So if you have a screen with a higher resolution than just HD, then I recommend you use this. I also have the random seeds set up so I can save the seeds I like. There is a short video on YouTube explaining what this does and an equivalent post on Instagram that you can save. Both I'll link to down below in the description of this video. And now we can get back and start making things. The most important step to do when using the Geomerative library is initialize it. And to do this, you can call the init method on the RG class and pass in the argument this or the keyword this to reference the sketch. This is an incredibly important step because nothing will work if you don't initialize the class or the library. Next, I'll walk you through the steps I take for loading any SVG really. Because I know that I'm going to load SVGs, one of the first few things that I do is call the ignore styles method. That ensures that if, let's say, I have a black stroke on my shapes, then this will ignore it and will allow me to create my own styles and add whatever colors I want or whatever stroke weight I want. But if you want to use the styles from your SVG, then you don't really need this. And this accepts a parameter, a Boolean argument. So if you want to, let's say with a mouse press, ignore the styles and go back to the original one, then you can do that. Next, I set the polygonizer length. This specifies the number of points on your path. The bigger the number, the less points you have. I use usually 10. When we later draw the points, we'll see how this number affects the spacing between points. But for now, we'll just set it to 10 and then we'll see how that changes. And you also call it on the RG class. And it's called set polygonizer length and you input the number that you want. Now it's time to load the shape. Geomerative has a class called rShape that is somewhat similar to pShape in processing. And following the Geomerative example, I'm just going to call it GRP for group because usually shapes are a collection of paths and that's why I'll also create a two-dimensional array called points of the rPoint type. So if we have one path in our shape, or in our imported SVG, then the first dimension of the array will have one element. To load the shapes, we'll call the static method load shape from the RG class. With our file name that is saved in the data folder inside our sketch folder, and assign this to the variable group. To get the name of my file, I'll go to the data folder where I saved it, and I can just grab it from here. And now if I view the shape in the draw method, I can just call RG shape and then group. You'll notice that it's down here. So what I need to do is center it in. And I can do that using the center in method. That will take the main canvas P graphics, which is G, and a margin. So let's say I'll make it 200. And then there are two other variables called scale damping and translate damping. I don't necessarily know what they do because I've never really tested anything, but following the example or one of the examples from the Geomerative library, you can just set them to 1. But there's also another center in method that only takes these 2 arguments, so you don't really need those 2. And now if I run this again, then I can see that the shape is centered in the or on the 0, 0 point. So what I need to do is translate the whole thing to the center. And this way I have my shape. And because I ignored the styles, so if I remove this and I change the background color to white, we'll be able to see the original shape. But now going back and ignoring the style will give me the default styles, which are fill of white and stroke of black. So I can just do no fill and maybe a stroke of white for now. And let's also make the stroke weight a little bigger so we can see it. And we have it perfectly in the center. Also note that if you save the shape with margins already, then this margin will add to that. So if I have 0, I should see the original shape on the canvas, how I created it in Illustrator, but this will allow me to scale it down if I want. So 200 for margins is good for this one. For Geomerative steps, we have one more, and that is get the points on the path and store it into the points2D array. And we can do that using group.getPoints in path or in paths, because I'm using the 2-dimensional array. If you are sure that you only have one path, you can use the getPoints in path, and you'll only need to do a 1-dimensional array over here. But because I know that some of the letters will have 2 paths, I'm using this. And I can assign this to my points array. Now let's view the points so we can check the set polygonizer length and what it does. And I can do that, or to display the points, we will do nested loops. The first one is going to be looping through the first dimension of the 2-dimensional array. And then the second one is going to be whatever is in the second, or the second dimension of the array, yes. Now I'll grab the X and Y positions from those points. So points at the first path, and then each point dot X, and then the same goes for Y. And now I can draw a circle at X and Y, and let's make it 10. Yeah, I'm gonna have to do this. I'll keep this over here, but I'll copy it and put it down here, because I need it to be after the shift of the canvas. And as you can see, here are the circles. Now if I go back up to set polygonizer length and I change this to 40, you'll see that I have fewer points. And if I have less than 10, then you'll see that they will start overlapping. But the value I like is 10, and it'll suffice for what I need to do with this. What I did after this is create an agent class, in which I have my guides, my brushes, and extra methods I may need. For the extra methods, I only have calculate angle and set color methods. For guides, I have this, so it's basically just a bunch of circles, so exactly what I did over here. And I'm gonna need a position for this, so I'll create a p vector. You don't really need to create a p vector, I just do it because it makes things shorter sometimes. And then I'll pass in 2 floats, and then assign x and y, whatever we pass in later, to this p vector, and now we have the actual positions. And this guides method is just to show me where each agent is to make sure things are working correctly. And the set color method allows me to specify a color from the main sketch based on any formulas I create there. The default color will be a random from an array. So what I do usually, define this here, we'll initialize it down here with a random value. And then we'll create one brush for this, a simple line because it's the easiest to demonstrate, and I'll later walk you through how I created my other brushes. I talk more in depth about creating generative brushes in my flowy noise course on Skillshare. Generally, whatever shapes you create in a function with a position parameter, you can use with this. So let's create our brush. And later we'll talk about calculating angles for our agents. For the brush, I'll use translate to move this shape where I want. So I'll need push and pop for that, just to make sure everything is secure in its own layer. This way I have more control over how the shape is drawn and positioned around the 0, 0 point, and that prevents unnecessary calculations. And that will take the position of the agent. And for the brush itself, I added 2 arguments. One I called angle, and the other one I called line width. So for angle, I'm just going to add the rotate method and pass in the angle. But for now, we'll keep it at 0, and then later we'll calculate the angle, as I said. And line width is going to determine how long I want the line to be. And I want the line to draw from the center. So what I'm going to do is draw it from negative line width divided by 2. So I'm basically cutting the line by half on the x-axis, and then I'm keeping it at 0 on the y-axis. So for the next x position, it's going to be line width divided by 2, and then 0 for y. So it's going to be a horizontal line on each of the x and y position, and it's going to be drawn from the center where the line width is going to go halfway to the left and then halfway to the right of that position, which is the 0, 0 point. That's why I said translate is going to help us make less calculations over here. Now let's go to the main tab and draw the agent, and it'll have the same length as the R point, or the points 2-dimensional array, and it'll also be a 2-dimensional array. I'm going to call it agents. And then the first dimension's length, it'll take the points.length, which is the first dimension of the points array. And then the second one, I'm not going to initialize right now. And it'll allow you to do this because it at least has a length over here. So everything here is going to be just 0. And now I'll use this loop to initialize or to create instances of the agents using the x and y position of each of the points. But before I do that, I'm going to have to initialize the length, or to add the length of the second dimension of the agents array. And that is basically agents at I is going to equal new agent array that is going to have the points at position I dot length. I mean, a two-dimensional array is basically an array of arrays. So that's what we're doing over here. And then inside of the loop, we'll just say agents at I, j is going to equal a new agent with x and y. And now in here, and with Command T or Control T, I can just format it. And in here, I can view the guides. So we have the circles again. And running this should give me green circles because I have it colored as green over here. And then I'll also display the brush. So agents at I and j. For the angle, we'll have 0 for now. And for the line width, you can have whatever. So I'm just going to start with 100. And you can see that we have horizontal lines that just stay that way. So if you come over here for this part of the A, it's overlapping lines that are all horizontal. And we need it to be vertical for this part. And then for these, I want it to rotate based on the curvature of the A. And then over here, it's going to be the same, but we were just lucky. So this is where the calculate angle comes in. I will go back to the agent class and I'll create the calculate angle method, which will return a float. So I'll call it calc angle, and it will take 2 arguments. I'm going to make them 2 p vectors. One is going to be the previous point and one is going to be the current point. And to avoid confusion, I'll just call it underscore position. And then it's going to return a tan 2, which basically takes the opposite over the adjacent and gives us the angle. And that will be whatever the previous point dot y minus position dot y, and then the previous x position minus the y of position, and these are going to be underscore actually. A10-2 returns the angle from the positive x-axis around the origin point or the 0, 0 point. And our 0, 0 point is currently in the center because we translated the canvas. So if we rotate using the y and x values of each point, you'll find that the lines rotate around the center point. So if I go back here, and let's say I want to calculate the angle right here. So I'll just say float angle. I'm going to call the method. Or actually, I'm going to show you how it rotates around the 0, 0 point. So if I take this instead, and let's just, so we don't have to write it again, and I'll calculate angle over here. And instead, this will just be the x and y position, which are these. And A10-2 just takes y before x, just a note. And then if I put angle over here, it should rotate around the center point. So it's all rotating around this part over here. And that's not what we need. So I'm going to just delete this and go back over here. And because what this is doing is grabbing the previous point and the current point, we're going to have to grab the previous point from this array and the current point. I can just grab it from the agents. So this is going to be the position and this as well. But this will be the previous point. And this will not work right now because it'll be out of bound, or actually calculate angle doesn't exist because I misspelled it. So now if I run this, we'll get array index out of bound exception because there is no j minus 1 because this will give me -1 since j is equal 0 in the beginning of this loop. So I'm gonna have to check for that. I'll initialize angle with 0 first, because if I put it inside of the if conditional, it'll act as if it's a local variable inside of if, and then I'll adjust it inside of the if. So this will grab whatever value is inside of the if conditional. And the if conditional is going to check if j is greater than 0. It's going to calculate the angle for that, and then it will rotate. Okay, found the error. It's right here. So it should have been x. Now if I run it, it should work. But it's following the path with lines vertically. So what I need to do is just remove half pi from that, and it should fix itself. Okay, but if you notice, for this point over here, because it doesn't have a previous point, it's not going to look right. So what I need to do is in the else area, or block is what people call it, I'm going to do the opposite. So instead of -1, I'm going to say +1. So it's going to calculate based on the next point. If you think about it, it's the same thing. A triangle can be flipped and it still have the same angles. And now if I run this, everything should follow the right angle. And if you want to remove the guides, you can just do if guides. So only if the guides boolean is true, then this will show. And I'll just call it over here, or initialize it over here. So I'll start it with true, and then with the mouse click, or when mouse is pressed, then I'll say guides is going to equal the opposite of guides. That way we can toggle between true and false. Now if I do this, if I click the mouse, then we remove the guides. If I click it again, then we show it. You can also do key press, where if you click the G button, let's say, then it'll toggle between true and false. That's up to you, depends on how complicated your program is. That's basically all I did with the path following algorithm, if you want to call it. And by the way, this goes for the text. So I said in my previous video that I'm going to section off the tutorial for following paths or text following paths into several parts. This is going to qualify for the second part because it's exactly the same way. I made it with sine waves, and this is the sketch that I showed on my stories. I haven't really taken it anywhere at the moment because 36 days of type was too early this year, and I had to just go back to doing all the things for, or what I planned for 36 days of type. But for that, so if we come back over here, and instead of the line, I said text, and let's just put the character A on each point, and then it's going to be at 0, 0. And this is going to have a fill, not a stroke. So I'm going to just put it over here. And that will be the color. And let's see if this works. Okay, so the A is actually following the line. And let's remove the guides. But if you notice, you'll see that the last one is actually rotating the other way. So what I did is just remove pi from it so I can flip it 180 degree. And I called the brush inside of the if conditional instead of just down here. That way I can have precisely the right angle. And you'll also note that this part is the opposite because it's still following the path, since this whole thing is just one path. So another way to look at this is to maybe specify how the path is drawn. Maybe you can separate those into 3 different parts, and you can then devise multiple scenarios for each of the different paths that you might be importing into your sketch. So for this part, let's say I want to add to it half pi. So I can rotate it clockwise, and so it's straight on the line. And basically, the more you're going to need this to be generative, the more complex your sketch is going to be. But for this, I'm just going to show you how you can follow the path, and maybe you can do whatever you want to do with it. And as promised, I'm going to walk you through how I created all of the other A's from my 36 days of type. For my fur brush, or the first brush, it was basically a loop with random lines that are offset randomly on each point of the line. And the thinner the lines, the furry it's going to look. The thicker the line, it's going to look more graphic. And for the second one that looks more like crayons, it's just a bunch of circles that are randomly offset on a rectangular brush. And I just used it to draw on the A path. They're just two very simple brushes, but really packed and really small, which made them look a little bit more organic. And then for the L animation, if you were wondering, let's actually bring it up. So for the L animation, because I only have one path, I could just do the first index and then the second index. I can just do it this way. So for the first index, it's going to loop through the agents.length. And I know for sure that I only have one path, so it's not going to be a problem. So when you do this frame count modulo, whatever number is here, it's going to go 0, 1, 2, 3 up to the number. So for this one, it's going to be 1. So the number is always going to be 0. But if you have a number that is 3 over here, it's going to be 0, 1, 2, 0, 1, 2, 0, 1, 2, and over again. So you can just do 0 over here, but I know for sure that if you have more than 1, so for A, it's going to have a glitch. So you'll have to make sure that it's not just every frame count, it's maybe every 30 frames, or once the first path is done, then you can move on to the next index in the first dimension of the array. Now for the second one, we're going to loop through the points. So what I did is just take the sine wave of the frame count, and then I multiply it by this just to slow it down. You can also do radians if you want it to be smoother. And then I mapped it from -1 to 1, which are the default values that you're going to get from a sine wave. And then map it to 0 to the agent's index.length. So the length of the points on that path. And then I constrained it just because sometimes map kind of goes rogue and there are values that are not in the range. So I just make sure to constrain it between the indices of the array, the first index and the last. And then I created two cursors. So this will act as my mouse. And cursor X is going to be agents at this index and then at this. So this will always be 0. And then the second one is going to be position Y. So the first one is going to be position X, and then the second one is position Y. And then I'm going to check the distance between the cursor. So I created a p-vector with that cursor, and then I grabbed the distance between the cursor and the current position of each of the agents. And then if that distance is less than 100, then I want the stroke weight to be mapped from 0 to 100, which is the distance, to map the distance from 0 to 100 to 3 to 10. So that will determine, or the distance between the mouse or the cursor and the current point is going to determine the stroke weight. And then I'm going to draw the brush over here. And the brush's length will also be determined by this distance. And then the other one, or whenever the distance is greater than 100, so whenever the cursor is really away from the points, then I'll only have a stroke weight of 3, and then I'll have a length of 100. So it's going to go back to its original state. And if I run this, you'll see that it's moving. So as the cursor is moving, the lines are actually getting thicker and longer. So if I actually remove this and make it 100, you'll see that it's only affecting the stroke weight. So if you want to do this with a letter that has multiple paths, just make sure that index is only going to move up through the array if one path is done with the animation, and then go to the next path. And I also did a one-way instead of a ping-pong animation. So for the one-way, it's going to be moving to the end, and then it's going to go back from the start. And let's get back to the line. And if I give it a different color, then we have a colorful brush. And I didn't talk about set color, but for set color, let me show you how I made the ones I had. So for set color, I actually mapped the color index based on the J points. So the J is the points inside of each path. And then I mapped it from 0 to the actual length of J, or where it's going to reach, and then from 0 to colors.length. And for this one, because I wanted to make sure that this other path is going to be from blue to purple, just to associate with the colors on each side, then I also did if I is going to equal to 1 and J is less than position I.length divided by 2, so half of it, then I want the color index to be the final color. Otherwise, I want it to be the second color, which is this one. And this is going to be the last color in the array. And that way I made sure the other path, so it's manual, but I made sure that the other path is going to have the same color halfway as the last color over here, and then the same as over here. Of course, you have to note that the way the path is moving is based on how the SVG is drawn. So if I go back to this SVG, and if I open it with a text editor, based on this, based on how the paths are actually drawn, this is going to draw. So if you notice that this line, let's say, is drawing before the A itself, then note that this is actually before this group, and you'll just have to switch it. And then also how the path is drawn over here. So these curves, how they're drawn, this is how this shape is going to be drawn. So for me, it's drawing from the right side to the left side when I actually want it to go from the left side to the right side. This can easily be fixed in Illustrator. You just can switch it. So you can rotate it, and that way you have that going before. Or if you know how to edit SVGs, then you can just do it directly in your text editor. So yeah, that's why I said this is manual, because what if actually my line is being drawn from this to this? Then this will be blue and this will be purple. So yeah, just be aware of that if things don't work out so the same way it is for me. And if you're wondering how these colors are actually shifting, if I go in here, and you'll see that inside of my display lines brush, for the hue offset, I created a hue offset variable. I gave it a value of 10, and I did the same for saturation and brightness. And then for hue, I gave it the color. For saturation, I gave it also the color, and for brightness, I gave it the color, and those are going to give us the hue and saturation and brightness values. And then I can add it to the stroke, and I randomize the offset based on these offset values. So I did the same for hue, saturation, and brightness. And then I gave it an opacity of 50. And that creates the shift in color, which makes it even more natural because fur doesn't really look all the same color. And that's it. It's just a matter of this, basically. So you can do any brush. You can make it follow a path. It's just putting it on the point, but calculating the angle between each point and its previous point to rotate it on the right x-axis angle is what's going to change the whole look for you. So yeah, I hope you found this helpful, and as usual, I'll talk to you soon.